Okay, the following are a couple of quick notes to help you with the parametric equations and vectors worksheet. The first thing is just a reminder, parametric equations. Those are the ones where you have an x equation in terms of t and a y equation in terms of t. The thing to remember for this is still that dy dx will always be the slope. The dy dt is the rate at which y changes in terms of t, and dx dt is the rate at which x changes in terms of t. Sometimes you'll see it written as dy dt and dx dt. Sometimes you'll see it written as x prime of t, y prime of t. Either way, you're going to be given one of these to be able to find dy dx. So when they ask for dy dx, when they ask for the slope, this is the equation you'll be following. Another thing to remember is to be asking yourself throughout all these questions, what do I have? What are they asking for? What do I need? Sometimes you won't be given x prime or y prime. You'll be given x of t, y of t, and still be asked for dy dx. If that's the case, you first have to derive it, derive x, derive y, and then be able to find your dy dx. Sometimes you'll actually be given dy dx. So every once in a while, what they'll do is they'll give you this one, and they'll give you this one, and you'll have to find dy dt. If that's the case, then you set it up as a regular equation, solve for dy dt, and so forth. So be careful. Always ask yourself, what do I have? What are they asking for? What do I need? And that should help you with that part. There are many applications of vectors. The one that we're going to be using is vectors will be a simplified way of being able to write a parametric equation. So here we have a parametric equation. We have x in terms of t and y in terms of t. You'll notice on the worksheet that you'll see this new symbol. It kind of looks like a bracket, and it'll be written like this: t cubed minus 2t squared plus 5t minus 1. There'll be a comma that separates them, and then you'll see the other one: 4t squared plus 3t minus 7. And notice we use these kind of brackets as opposed to parentheses. It's just our easiest way of being able to write an x component and a y component. Later on, we probably won't get to it this year, but we might, just for fun, after the AP exam, we'll do, x, y, and a z. And that just means that there will be a third dimension that we'll be working with. But for right now, we're just going to be working in 2 dimensions. This is just an easier way of writing x and y. For right now, I'm going to say this is what I call my position vector. So I can say P of t equals, here's my position vector. An application that you'll be using on this worksheet is that we can go from a position vector to a velocity vector to an acceleration vector. And I'll show you how to do that with this quick example. The velocity vector for this is just like we found it before, but we're going to write it this way. We'll just worry about our x and our y's. Let's just first worry about our x vector. Is t cubed minus 2t squared plus 5t minus 1. Our velocity vector would be 3t squared minus 4t plus 5. And our y component for our velocity vector would be 8p plus 3. Notice all we're doing is we're doing what we've done before, where we're just deriving x, deriving y, and placing it in their in respective fields. I can also find my acceleration vector by, you guessed it, deriving my velocity vector. So it would be 6t minus 4 and 8. Okay. So this is just an example of how we can, given a position vector, find a velocity vector or an acceleration vector. I could ask you, what is the position at time t equals 2? In that case, you just have to plug in here and you will get an answer. I can ask you for the velocity at t equals 5 and so forth. You kind of get the point. One thing that you have to be careful with is, if I give you a velocity vector, how to find a position vector. I think you guys probably guessed it, that since I derive going this way, that I antiderive working backwards. That being the case, please remember that when you antiderive, you need a plus c, and then you're going to have to solve for that plus c. So that's still the same thing that you've learned before. People seem to forget that. So again, remember, if you're antideriving, if you have velocity vector, you need a position vector. When you antiderive, you need a plus c to solve for that. The only new thing is that you're going to do this twice. You're going to do one in terms of x and the other one in terms of t. Another thing you'll need to know about to complete this worksheet, a couple problems to talk about speed. In order to talk about speed, I first want to talk a little bit more about what vectors are. If you remember, vectors are a component that's made up, their value sometimes, they're made up of two components. One of them is its size, or its what we call magnitude, and the other one is a direction. Notice here I have a vector that is going up this way. This will be its direction, and it has a certain length to it. One way we can talk about the vector is through its direction and its length. The other way we can talk about a vector is its x component and y components. Meaning that if this x component is 4 and the y component is 3, remember it's written like this: 4, 3, they should be able to tell me the size of this vector, or in other words, its magnitude. And obviously I picked nice easy numbers so that we can realize that its magnitude is 5. Okay, so now the question is, given a vector, how do I find its magnitude? Hopefully you've recognized that it's just the distance formula. It is the square root of the change in x, or in this case the x component, 4 squared, plus the change in y, or in other words the y component, which is 3 squared. And if you do that, you would get 5. So here's another example. If I had a different vector here, let's call this this vector, and I said that this distance is 12 and this distance is 5. Notice now we have a different vector whose value would be negative 12, 5. So we go in a negative 12 direction, and going left 12 and going up 5. What's the magnitude of this vector? It's 13. And notice its direction is different than this other vector over here, but the magnitude is still found the same way. In other words, a distance formula. So how do we find the magnitude of a vector that is x of t, y of t? Well, if this is my vector, its magnitude is going to be the square root of x of t squared plus y of t squared. And this is known as the magnitude of the vector. The reason this is important is because speed is defined by this word. Speed is the magnitude of the velocity vector. Okay. So a quick example of that would be, let's say I have a vector, and we'll call this a position vector, which is 3t minus 7 and 4t squared plus 1. If this is my position vector, how do I find the speed of the particle whose position is defined by this vector? Well, the way we find speed is I need my magnitude of the velocity vector. So the first thing I need to do is find the velocity vector. The velocity vector would be 3, 8t. We have our change in x with respect to time and our change in y with respect to time, and that gives me my velocity vector. I would like to find the speed at t equals 2. Well, at t equals 2, the velocity would be 3, at t equals 2, the velocity vector is 3, 16. That's my velocity. Notice that this has two components, as an x component and a y component. But when I want to find speed, I have to take the square root of my velocity vector. Or in other words, the speed at time equals 2 would be the square root of 3 squared plus 16 squared. Put that in your calculator, and that'll be your speed at time t equals 2. The best way I can describe this is that whereas position could be positive x and positive y, or negative x and negative y, or a mixture of the two, you always remember that distance will always be positive. Where your position can be in any of the 4 quadrants, the distance is always going to be positive. Similarly, with speed and velocity, our velocity can be positive, our velocity can be negative. One means that we're going to the right, to the left, up, or down, but our speed will always have to be positive. So that's the way that I remember that. The connection of speed to velocity is kind of the connection of distance to position. So in those problems where they ask you for speed, again, you have to ask yourself, what do you have? What are your givens? What do you need? And what are they looking for? If they're looking for speed, you first need to have a velocity vector and then find its magnitude, and that'll give you speed. These are the notes that should help you for all the worksheet. I would expect that work should take you probably about 2 days, and you guys working on that 2 days in class, work together, ask me questions on the blog, and I'll be able to answer them more specifically. Have fun.